Hey Finxters, let's discuss how to check if a list is nested in Python. So before proceeding further, let's have a quick look at what's a nested list and what's a flattened list. A flattened list is nothing but a simple list. For example, li_1 equals 1, 2, and 3. So this right here is an example of a flat list. So what's a nested list? Now a nested list is nothing but a list containing more lists. So let's have a look at an example which will help us to understand what is a nested list. So I'm naming it li_2 and this is a list. And now within this list, we have couple of more lists. So the first list has the following elements 1, 2, and 3. And the second list has elements 4, 5, and 6. So I hope the difference between a flat list and a nested list is clear to you. Now let's get back to our discussion. Suppose you have a list that is nested at times, while sometimes it is not nested. Now based on whether it is nested or not, the continuation of your program would depend accordingly. So how would you differentiate between a nested list and a flattened list? In this lecture, we are going to have a look at 3 methods which are going to help us to differentiate between a flat and a nested list. So in the first method, we are going to use the isInstance method and the any method to resolve our problem. Now before we use these methods, let us try and understand what are these methods. Starting with isInstance method, it is a built-in method in Python which returns true when the specified object is an instance of a specified type. Otherwise, it returns false. Now to make things more clear, let us have a look at the syntax of this method. So as you can see, we have the method isInstance, and within the method we have couple of attributes. The first is the object which has to be checked, and the second attribute is the class info. This is the type or the class which you want your object to match with. For example, if the object is an integer which has a value 25, so 25 will be your object, while the class info would be int, which is integer. Now let's have a more clear idea about this with the help of an example. So let's move on to our programming window. And now we have the variable a, which stores the output of the isInstance method. And this method is checking if 25 is an instance of the integer object. Now since this is true, we should obviously get the output as true. Now for a better understanding, let us also create another variable. Let's name it b. And now let's insert a string a. And now let's check if this is an integer or not with the help of the isInstance method. And now in this case, the output should be false. So let's go ahead and use the print statement to check if the output is false. Now let's go ahead and execute our code. And there we go. As you can see, in the first case, a, which is indeed an integer, that is 25, is of the type integer, so we get true. While in the second case, b, which stores the output of the isInstance method, that is checking if a, which is a string, is an integer or not, will return false because of course a string is not an integer. So I hope the isInstance method is clear. Now this brings us to the next method. The next method that we are going to discuss is the any method. So the any method is a built-in method in Python that returns true if any element in a given iterable like a list is true. Otherwise it returns false. Now let's go ahead and understand the any method with the help of an example. Suppose you have a list li, and within this we have couple of elements. The first element is false while the second element is also false. Now let's try and visualize the output given by the any method when we feed in this list into the any method. Now as per our discussion, the output should be false because our list li has no element or no item that is true. So in this case, our output should be false. Let's go ahead and check this. And as you can see, the output is false. Now what if we make a slight change here? We add another element which is true. And now what should be the output? Let's go ahead and check that. Right click and run our program. And now in this case, we have true as the output. This is because our list now has a value which is true. That's why the any method returned true as the output. Now we have a clear understanding of the is instance and the any method. It's now time to use these methods and check if a given list is nested or not. So let's move back to our programming window. And now we have our lists li_1, which is a flat list, and li_2, which is a nested list. I will now create a variable res_1, which will store the output of the following. Now I'm going to use the any method, and within this any method, I'll use the isInstance method. And now with an isInstance method, I'm going to check if I is of the type list, where I represents an element within the given list. So for I in li_1. Now to understand what's happening here, let us break it down and try to visualize what's happening. So let's try and store the output of this part in a variable x. And this variable is a list, and this list stores the output given by the part that we selected. So what this means is the isInstance method will check each element within the li_1 list and match it with the type list. So in the first case, it will find if 1 is a list. Of course, it is not. It is an integer, so it will return false. In the second case, it will find and match 2 and check if it is a list or not. Again, it will be false. And similarly for 3, it will be false again. So let's go ahead and print x and let's visualize the output. And as you can see, it's false, false, and false. Now when we feed this output to the any method, it will again return us false. This is because the output that was stored in x had no element which was true. Therefore, we get the output as false. So what does this signify? This means that our list li_1 is not nested. So let's check it out here. Is li_1 nested? And now let's execute our code. And as you can see that the output is false. So we have successfully checked if li_1 is nested or not, and in this case it is not nested, so the result is false. Now to optimize our code, we do not need these sections of our code. All we need to do is use the print statement, and then the output is already stored within our res_1 variable. Now let's go ahead and follow the same procedure for our list li_2, which is indeed a nested list. So in this case, I'm going to store the result within a variable res_2. And now I'll check the values for this list, which is li_2. Now yet again, let's go ahead and break this down so that we have a clear understanding of what's going on. So x equals, and then let us copy this section of our code and let's store it within the variable x, which is a list. And now let's go ahead and print x to visualize the output. Now let's execute our code. And as you can see, this time the output or the list x stores the values true and true. How come? This is because in the first case, li_2 has an element which is a list again. So this is a list. So when the isInstance method checks if this element is a list or not, it yields a value which is true. While in the second case again, this is a list. So the second value or the second element is true again. So that's how this piece of code works. Now let's go ahead and optimize our code again. We do not need this piece of code. And all we need to do is check if li underscore 2 is nested or not, and then the result is already stored within the variable res underscore 2. Now let's go ahead and execute our program, and there we go. Is li underscore 2 nested, and the output is true. So that's how you can check if the given list is nested or not with the help of the isInstance method and the any method. With this, we come to the end of our first method of checking if the list is nested or not. Now let's move on to the next method. The next method is going to use the isInstance method once again, and along with it, we are going to use the len method within a for loop to check if the list is nested or not. Now, without going into theory, let us have a look at the program itself so that things become clear to us. So let's move on to our programming window. Let's clear out this piece of code because we do not need it anymore. Now let's create a function by the name count, and it accepts an argument. Let's name it L. Now within this function, I'm going to create a counter variable. I'm going to name it flag, and let's initialize it with the value 0. Now what is this counter variable going to do? This counter variable will help us to keep a count of the number of elements in the list. Now let's create a for loop which will allow us to iterate through the elements of the list. So for I in L, which is our list, and now within this we are going to use the if else statements to check if the item is a list or not. So what do I mean? Let's define our if block. So if, and now we are going to use our isInstance method, and within this method we are going to check if I is a list. If it is so, then we are going to make changes in our flag variable, which is the counter variable. So we are going to say flag equals flag plus, and now we are going to use the len method. So len, and inside it I. So what am I doing here? I'm checking if I is a list or not. For example, when we pass li underscore 2, in that case the first element is going to be a list. So the control will move inside the if block because I is indeed a list. And now what it will do is it will add the value of the length of this list. That means the len of li underscore I for the list li underscore 2 is going to be 3 in the first case and again 3 in the second case. So this output should be 6. Now let's define our else block, and within this else block we are going to define the condition when the item is not a list. Now when does that happen? That happens when we have a list which is not nested. In that case, the first value, which is 1, it is just an integer value. It is not a list. So that means the control will move into the else block. And in this case, we are going to say flag equals flag plus 1. And now finally, we are going to return the value of our flag variable. So when we pass li underscore 2, the output of the flag variable should be 6. While when we pass our list li underscore 1, the value of the flag variable is going to be 3. So that's it. We are done with our function now. And now let's create a variable x and let's pass the list li underscore 1 in our count function and another variable which stores the result when we pass the value of our list li underscore 2. Now here's the trick, which is going to help us to decide if the list is flat or nested. Let's use the print statement is li underscore 1 nested. And now we are going to use the Boolean function bool, and within this we are going to perform a certain check. So what are we going to verify here? Let's see. We are going to check if the value of x, which is going to be 3, is not equal to the length of the list, that is li underscore 1. Now what do you think would be the output of this expression? It's going to be false. This is because x, which is equal to 3, is definitely equal to the length of our list li underscore 1, whose length is also 3. So therefore the output of this statement is going to be false. Now in the second case, we are going to perform a similar check, but this time we are going to do that for our variable y. We are going to check if y is not equal to the length of the list li underscore 2. Now what's happening in this case? In this case, y, which has the value 6, is actually not equal to the length of the list li underscore 2. Why so? This is because the length of our list li underscore 2 is 2. This is because li underscore 2 has couple of elements. This is the first element, which is a list, while this is yet again another element, which is another list. So the total number of elements within li underscore 2 is 2. Please do not get confused in this part. Li underscore 2 has a length of 2. But the list within li underscore 2, that is the first list within li underscore 2, has a length 3, while the second length has a length of 3 again. Therefore, when we try and compute the number of elements or the total number of elements within li underscore 2, such that we are also taking each list that is within li underscore 2 into account, then the output is 6. However, when we are simply trying to calculate the length of the list li underscore 2, it will return us a value of 2. Therefore, 6 is not equal to 2. Hence, when we perform this check, we are going to get a value which should be true. So now let's go ahead and execute our code. Before we proceed further, I can see that we have not provided the correct indentation for our flag variable, or to say we have not provided the correct indentation for our return statement, and that might lead to an erroneous output. So let's provide the correct indentation to get the correct output. Okay, we have got all things into place now, and now let's go ahead and execute our code. And there we go. Oops, not perfect. In the second case, we should check if li underscore 2 is nested or not. And now let's go ahead and execute our code once again. And there we go. So in the first case, is li underscore 1 nested? No, it isn't. So the value is false. While in the second case, is li underscore 2 nested? Yes, it is. So the output is true. Now that brings us to the final method, which will help us to decide if the list is flat or if the list is nested. Let's go ahead and have a look at this method. Now I call it the numpythonic way of resolving our problem. This is because in this method we are going to use the numpy library. So what we are going to do in this method is that we will convert our list into an array, and then we will check if the dimension of that array is greater than 1. Of course, if it is greater than 1, then that means it is nested, whereas if the dimension is less than 1, it means that it is not nested. Now remember, if the array or if the list has elements which are integers, this means all the values should be integers. It cannot be that one value is an integer while another value is a string. In that case, this method will not work for you. However, if all the elements within the list have the same type, then in that case, this method will work perfectly fine for you. And within the NumPy library, we are going to use couple of methods. The first one is going to be numpy.array. This will help us to convert our list into an array. And then we are going to use the ndim method, which will help us to determine the dimension of that array. So let us quickly go ahead and implement this and check if this works for us. So as I mentioned, our first requirement is to import the NumPy library. So import NumPy as np. And then we have our lists li_1 and li_2. And now it's time to convert these lists into an array. So I'm going to call the first array as a_1. And then let's go ahead and use the NumPy library and the array attribute or the array function to convert our li_1 list into an array. Similarly, for the li_2 list, we are going to convert that and store it into a variable or an array which goes by the name a_2. So a_2 equals np.array, and within this we are going to pass li_2. Okay, we have now successfully converted our lists into arrays. It's now time to check the dimension of these lists. So we will do that with the help of the boolean method bool, and then we are going to check if a_1 dot ndim, which helps us to retrieve the dimension of the array a_1, and then check if it's greater than 1. So if this condition is true, then in that case our list will be nested, while if it is not, then it will not be nested. So let's use the print statement and check if or is li_1 nested. And let's repeat the similar procedure for our list li_2, which was converted into an array that went by the name a_2. Now, according to our lists, li_1 is a flat list, while li_2 is a nested list. So the first print statement should return false, while the second print statement should return true. So that's how simple this was. Let's go ahead and execute our code. And there we go. As you can see, in the first case, li_1, which is a flat list, has returned the value false, while in the second case, li_2, which is a nested list, has returned the value true. With that, we come to the end of this lesson, and I hope each method was clear. In case you face any problem or any doubt, please mention them in the comments below. I'll try my best to answer your queries. I'll also provide a link to the article with respect to this lesson so that you can go ahead and use that for your reference. Thank you.